The door open.
Yeah.
And then the cylinder then charges 300 psi.
And that's this here?
Yeah.
There's a huge technical challenge with the inflation of such a large device. To inflate something the size of an aircraft life jacket, a small canister can provide enough air. But the same system would require a 3-metre-long canister on an escape chute. So instead, when triggered, the canister of compressed carbon dioxide and nitrogen delivers only an initial boost. The clever technique is that these gases are forced through a narrow gap, which causes them to accelerate rapidly. This acceleration creates a vacuum that then sucks in enough ambient air to inflate the entire slide in 3 seconds.
That was pretty quick.
Yep.
3 seconds, we happy with that?
Yeah.
Wow. And look at it, I mean, it's
Solid there.
absolutely solid.
Testing the escape chute is the easy part. Now, like a parachute, the 30 square meters of material must be folded precisely back into its container, measuring just half a square meter.
And that'll take how long?
6 hours of hard labour.
Wow.
It's as much an art as science. It's all too easy to take flying for granted. As passengers, we're oblivious to the fact that the enormous metal tube we're travelling in is flying through the air at close to 600 miles an hour, and at a height similar to Everest, an atmosphere unable to support life. Engineer Gavin Beverstock is showing me how Victor X-ray pumps air from its engines into the cabin to create an atmospheric pressure similar to conditions on the ground.
Traces through. Due to rise in altitude means a decrease in pressure, but also due to comfort for passengers. It has to be maintained, because obviously when we're on the ground we're at 14.7 psi, and as you're rising through the air it reduces down, and once you get below 10 psi it's not very comfortable. You can start having breathing problems, and it is so thin that you will struggle.
But the greater the pressure of air that these pipes pump into the cabin, the stronger the fuselage needs to be. That would add weight to the aircraft. So there's a compromise. Planes usually fly with a pressure equivalent to between 6,000 and 8,000 feet, comparable to the world's highest cities. That means reduced oxygen, and is one of the reasons we often feel tired on a flight. Pressurizing the cabin can also cause metal fatigue, because as air is pumped in and out of the aircraft, its fuselage expands and contracts.
You can see all the dimples along the skin of the plane, which when it's pressurized up in the air all gets smoothed out.
It's a pretty amazing bit of engineering, but this frequent flexing of the fuselage can cause cracks. It's one of the major reasons why Victor X-ray is undergoing this intensive operation.
In order to thoroughly examine every inch of the airliner's internal shell, engineers have to remove almost every fixture and fitting inside the cabin. Some 747s can take over 500 passengers, but airlines can use tracks in the floor to choose their own seating plan. On Victor X-ray, Mick Gregg and his team must strip out 299 seats.
Mick, with the right Allen key, to just sort of steal yourself a bit of extra leg room in flight? Would that, yeah.
No, it wouldn't. Not unless you got a ham and a drift with you as well.
You'd never get past security, would
No, you wouldn't.
They are light. They're lighter than a settee, aren't they?
Yeah. There you go, Tom. Done.
Once removed, Victor X-ray seats are sent to the interiors workshop to be reupholstered and put through their paces by veteran seat tester Mark Jago.
So is it your job then to sit in this chair, watch a few films, play a few games and then say, yeah,
yes,
we're good?
It's a terrible job, but somebody's got to do it.
Back in the hangar, work continues in the cabin.
All these side walls are yet to come out. All the dados on the bottom are all to come out.
300 floor panels must be removed.
All the centre trough area there gets reworked.
180 window protectors and blinds taken out, and 140 sidewall panels stripped off.
Oh, here we go.
This is the skeleton of the plane here. This is the, behind here, that's the framework. Aluminium frame?
Yeah, it's all aluminium. Won't have steel. Steel's too heavy. You want your aircraft to be as light as possible, don't you?
And that installation is pretty vital, isn't it? 'Cause it's sort of minus 50 degrees outside there.
Yes, it is. I believe it's about minus 56 degrees, around 30 to 35,000 feet.
And that's enough to protect you from that
Yeah.
minus 50 odd outside.
It's 2 days into the overhaul, and most of the first-class cabin fittings have been removed. The team can now begin the painstaking task of searching every inch of the internal frame for the smallest of defects.
And lo and behold, we found a little crack down in the corner, which we're going to put right, yeah. Your favourite seat, 1A?
1A is my favourite.
Shift manager Paul Thomas has discovered a minor crack in one of Victor X-Ray's floor supports.
Which is right in the corner. You can see the telltale, and it runs right to the corner. They normally emanate from fastener holes, so a rivet, and then run out.
Or sharp edges, you know. Or...
Yeah, well, you can see the line
Yeah,
in this
yeah.
tracking. So, yeah, we pretty much got to replace that part now.
And you visually inspect the whole structure?
Absolutely. If we don't take that out now, that crack will just run and run and run and run and run. So we found it now. So the floorboards will come up. We'll de-rivet all this area.
Just for that, I mean, that...
Just for that small little crack.
Yeah.
Reassuring, yeah?
It is reassuring, but yeah, because I mean, my car is, you know, call that a crack. I'll show you cracks.
No laybys at 38,000 feet, I'm afraid.
There are no laybys in the sky. There are no laybys in the sky.
Absolutely.
Yeah.
It's day 4 of the overhaul, and work's beginning on Victor X-Ray's largest components, its wings.
Really, from wingtip to wingtip, we're looking at about 211 feet. So
How big is that?
a huge wingspan.
That's about a football pitch, then?
About a football pitch, yeah.
Overseeing the work on the aluminium and carbon fibre wings is shift manager Chris Morgan.
Obviously they're very sturdy, but there's quite a bit of movement, isn't there, in the actual...
Yeah, so I mean, if you can see this movement here now, you get a total
Very
displacement up and down is about 32 feet. That's because you don't want a wing to be rigid. They need to allow for turbulence, they need to allow for airflow.
How air flows around a wing is crucial to achieving flight, and yet, incredibly, even among experts there are different theories to answer the question, how does a plane fly?
And most people have that question answered with Bernoulli's theory. And Bernoulli's theory suggests that air going over the top of the wing has to travel further than the air underneath. Because it's got to travel further, it speeds up. Because it speeds up, the air particles spread out and diffuse.
This results in lower pressure above the wing than the pressure beneath. That pressure difference literally pushes the plane into the air. But this doesn't explain why planes can fly with symmetrical wings. In fact, it's the angle of the wing and the amount of air it deflects down that matters. Because according to Newton's third law, the air force downwards results in an equal and opposite force upwards onto the underside of the wing. At the right speed and angle, this is enough to lift the plane into the air. In flight, Victor X-Ray's wings are subjected to enormous forces. Apprentice Lewis Robinson Hoare has been scouring the surface of this wing to find any damage that may have occurred.
We found some damage during inspections, which the damage is round there, where all that is pulled away from the structure below it.
Okay, so the composite started to come apart.
Defect spotted. It can now be repaired. It turns out that Lewis's engineering passion runs in the blood.
3 generations of my family have worked there, so it's just run with the family, I suppose.
Yeah. And are they on shift with you sometimes?
No, my dad's on the opposite shift to me.
Okay.
Which is okay. And my Bampy's retired now.
Yeah.
So, but he used to work in here as well.
Lewis's next job is on Victor X-Ray's flaps, vital components which increase the surface area of the wings, allowing aircraft to fly at slow speeds. The only way the crucial hydraulic and backup electrical control systems can be thoroughly checked is to remove the flaps. Lewis has to control this crane with absolute precision.
The crane has been set to 0.9 of a tonne, which is the exact weight of the flap they're removing. That's so when the last guy undoes the last bolt, the wing doesn't drop to the floor or fly to the ceiling.
Is she off? OK.
Slowly but surely, the flap is removed from the wing, with barely a millimetre of movement up or down.
Let him go. He's all the arse out, all right?
Look at his face, he's loving it.
During flight, air passes over these flaps and wings at hundreds of miles an hour. That causes friction and the build-up of static electricity. To deal with that, there are small attachments, known as static wicks.
If you could see it, how would that static look coming off here? Does it just sort of fizzle out?
Literally that. Visibility-wise, it's often very hard to see.
Yeah.
But you will still get sparking that will occur.
Slight sparking, right?
Yes. Sometimes in the high, electric storms and certainly in a lightning strike, we will get these like sacrificial. They will take a little bit of a battering.
On average, every aircraft is hit by lightning once a year. So how does a plane deal with this phenomenon? This laboratory at the University of Cardiff holds the answer, because this is one of the few places in the world where scientists, led by Phil Likauer, have the technology to make lightning of their own.
It might sound bad doing these lightning tests to planes and things, but absolutely everything on an aircraft has to be certified against all the threats it could be posed to it.
The state-of-the-art laboratory tests new materials as aircraft manufacturers look to find lighter, more cost-effective alternatives to the aluminium currently used. So why do planes get hit by lightning?
The aeroplane, since it's actually in the sky, it's a huge metal object, it induces the lightning strikes itself, because it's the only thing there.
So how do planes survive? To find out, we're going to test this aluminium model, similar to our own 747.
Let's blow it.
OK.
You might have the best job in the world.
Sometimes I think so. There's a lot of paperwork too, though.
Now, it's my chance to play God.
Basically, when I say fire, it's very easy. Just press fire. And fire. So as you see, the model aeroplane survived.
It did. It looks perfectly intact.
Everything and everyone inside a plane's protected by the aluminium fuselage, which is a good conductor. It allows the electricity to take the path of least resistance, along the fuselage and out again.
What would the passenger feel?
They might hear a loud thump, but that's about it. They shouldn't feel anything at all.
A graphic experiment illustrates the dangers of using a non-conducting material, in this case plastic.
Fire.
Which is why all new material combinations are so extensively tested. Back at the hangar, work to strip back the 747 continues. Today, engineers are about to reveal one of the parts of the plane that the public never sees. The nose cone, or radome as it's known, shields the aircraft's weather radar, which needs to be checked for corrosion.
And it works on the radar principle, which is like a complicated echo. It fires out radio waves in a very, very fine focus. It fires a beam out and then listens to that beam coming back, which will bounce off any clouds or anything that's up ahead. And that information is fired out at different angles to allow a huge range of sight, which is fed back to the flight deck so the pilot can take whatever action he needs to take.
Victor X-ray is now a week into its overhaul, and next, its most valuable components are about to be removed for closer examination.
It is a big moment indeed. They're actually taking the engine off the wing. These things cost about £8 million each. The last thing you want to have happen is it come crashing to the floor.
As experienced as he is, it's a nervous moment for